Download this code from codegive.com, link in the description below. OK, let's dive deep into effective Python package management, inspired by best practices and drawing upon Devon Bernard's work where applicable, though not necessarily directly attributable, as package management is a broad field. This tutorial will be comprehensive, covering various tools, concepts, and practical examples. Introduction. Why is package management important? Python's strength lies in its vast ecosystem of libraries and packages. Proper package management is crucial for reproducibility, ensuring your code runs the same way on different machines, development, testing, production. Dependency management, tracking what libraries your project relies on and their versions. Isolation, preventing conflicts between different projects that might use different versions of the same library. Collaboration, making it easier for others to contribute to your project or use it. Security, being aware of security vulnerabilities in your dependencies and updating them. 2. Core concepts. Before we delve into specific tools, let's clarify some key concepts. Packages, reusable collections of modules, Python files. Think of them as self-contained units of functionality. Examples include NumPy, requests, pandas. Dependencies, the packages that your project needs to function correctly. A project can have direct dependencies, those you explicitly install, and transitive dependencies, the dependencies of your direct dependencies. Virtual environments, isolated Python environments that allow you to install packages specific to a project without interfering with other projects or the system-wide Python installation. This is the cornerstone of good package management. Dependency specification, the process of clearly defining which versions of your dependencies are required or compatible with your project. Package index, a repository where packages are stored and can be downloaded. The primary package index for Python is the Python package index, PyPI. Resolving dependencies, the process of determining which versions of your dependencies to install to satisfy all requirements without conflicts. 3. Essential tools. Here are the primary tools you'll use for Python package management. 1. Venv, or virtualenv, for creating and managing virtual environments. Venv is part of the Python standard library, since Python 3.3. Virtualenv is a third-party library used with older versions of Python. 2. Pip *, the package installer for Python. It's usually bundled with Python. Pip is used to install, upgrade, and remove packages from PyPI or other indices. 3. Requirements.txt *, a simple text file listing the dependencies of your project. This file is a common way to specify dependencies, but it has limitations, which we'll discuss. 4. Setup tools *, a build system for Python. It's used to package and distribute your own projects. 5. Wheel *, a distribution format that makes installation faster and more reliable. Pip usually uses wheels when available. 6. PyProject.toml *, the modern standard for Python project configuration. It is designed to replace setup.py and setup.cfg. 7. Poetry *, a dependency management and packaging tool that aims to simplify the entire process. It uses PyProject.toml and takes a holistic approach. 8. PyPenv *, another dependency management tool that combines virtual environment management with dependency resolution. It's often considered a more modern alternative to requirements.txt. 9. Conda *, a cross-platform package, dependency, and environment management system. It's particularly popular in data science due to its ability to manage non-Python dependencies, like compiled libraries. 4. Practical workflow with venv and pip, basic approach. This is the most fundamental approach. It's good for simple projects. Step 1. Create a virtual environment. Step 2. Activate the virtual environment. *Linux/Mac OS *. Windows, Command EXE. *Windows, PowerShell. You might need to enable script execution in PowerShell if it's disabled by default. Important * your shell prompt will change to indicate that the virtual environment is active, usually with the environment name in parentheses, example myprojectenv. Step 3, Install packages. Step 4, Create a requirements.txt file. This is used to record the exact versions of your dependencies. This command creates a file named requirements.txt in your project directory. It will contain lines like this. Step 5, Install from requirements.txt, reproducibility. On another machine or in a new environment, you can install the exact same dependencies. Step 6, Deactivate the virtual environment. When you're finished working on the project, deactivate the environment. Example code snippet. To run this code *. 1. Create the myprojectenv virtual environment, as above. 2. Activate the virtual environment. 3. Install the required packages, pip install requests numpy, or pip install our requirements.txt if you've created that file. 4. Run the script, python my_script.py. v. Advanced Dependency Management, Poetry. Poetry offers a more sophisticated approach to package management, addressing some of the limitations of requirements.txt. Why Poetry? Dependency resolution. Poetry uses a solver to find compatible versions of dependencies, minimizing conflicts. PyProject.toml. It uses PyProject.toml for project configuration, which is the modern standard. Packaging. It simplifies the process of building and publishing your own packages. Locking. It creates a poetry.lock file that captures the exact versions of all dependencies, including transitive dependencies, ensuring perfect reproducibility. Virtual Environment Management. Poetry manages virtual environments for you. Installation. You may need to add Poetry to your path. Follow the instructions from the Poetry website for your operating system. Basic workflow with Poetry. Step 1, Create a new project. This creates a directory structure like this. Step 2, Add dependencies. Poetry will automatically update the pyproject.toml file and the poetry.lock file. pyproject.toml example. Step 3, Install dependencies. This reads the pyproject.toml and poetry.lock files and installs all the dependencies into a new virtual environment, managed by Poetry. Step 4, Activate the shell, virtual environment. This activates the virtual environment managed by Poetry. Alternatively, you can run commands directly within the Poetry environment using Poetry Run. Step 5, Run your code. Step 6, Building and Publishing, optional. Poetry Build creates distributable packages, will and source distribution. Poetry Publish publishes your package to PyPI, requires configuration. 6. PyPenv, another alternative. PyPenv is another popular tool that combines virtual environment management and dependency resolution. Installation. Workflow. 1. Create project directory *, make a directory for your project. 2. Initialize pypenv*. This creates a pip file and pipfile.lock. 3. Install packages *. 4. Activate the virtual environment asterisk. 5. Run your code within the shell. 6. Install all dependencies from pip file. 7. Conda, data science focus. Conda is particularly well suited for data science projects because it can manage both Python and non-Python dependencies. Installation. Download and install Anaconda or Miniconda from the Anaconda website. Workflow. 1. Create a Conda environment asterisk. 2. Activate the environment asterisk. 3. Install packages asterisk. 4. Export environment, reproducibility. 5. Create environment from environment.yml asterisk. 8. Best practices and considerations. Asterisk always use virtual environments asterisk no exceptions. This is the foundation of reproducible Python development. Asterisk use a dependency manager asterisk choose Poetry, Pypenv, or Conda, or a similar tool, over manually managing requirements.txt for complex projects. These tools handle dependency resolution and locking much better. Asterisk specify version constraints asterisk in your pyproject.toml, pip file, or requirements.txt, use version constraints, example requests equals 2.20, 3.0, to allow for bug fixes and minor updates while preventing breaking changes. Understand the meaning of caret, equals, and other version specifiers in your chosen dependency management tool. Asterisk commit your lock file asterisk always commit your poetry.lock or pipfile.lock file to your repository. This ensures that everyone working on the project uses the exact same dependency versions. Asterisk separate development and production dependencies asterisk use separate sections for dependencies needed only for development, example testing libraries. This reduces the size of your production deployments. Tools like Poetry and Pypenv make this easy. Asterisk regularly update dependencies asterisk keep your dependencies up to date to benefit from bug fixes, performance improvements, and security patches. However, be cautious about major version updates, as they might introduce breaking changes. Test thoroughly after updating. Asterisk pin transitive dependencies, use with caution while dependency managers like Poetry lock transitive dependencies, explicitly pinning them can be useful in extreme cases where you need absolute control, or dealing with bugs in particular versions of transient dependencies. Only do this if you know what you are doing, as it can cause complex dependency resolution problems. Asterisk understand dependency resolution asterisk familiarize yourself with how your chosen dependency manager resolves dependencies. This knowledge will help you troubleshoot conflicts and understand why certain versions are chosen. Asterisk security scanning asterisk use tools to scan your dependencies for known security vulnerabilities, example safety, pip audit. Integrate this into your CI/CD pipeline. Asterisk test your code asterisk thoroughly test your code after any dependency changes to ensure that everything still works as expected. Automated testing is essential. Asterisk choose the right tool for the job asterisk Venv and pip are suitable for very simple projects. Poetry, Pypenv, and Conda are better choices for more complex projects with more intricate dependency requirements. Conda is particularly well suited for data science. 9. Devon Bernard and related resources. While I cannot directly attribute specific package management practices directly to Devon Bernard, as I don't have access to specific unpublished works or internal training materials, his focus on developer tooling and efficiency makes these principles very relevant to his domain. To learn more about related topics and best practices, consider exploring these resources. Asterisk the official Python documentation asterisk https://docs.python.org/3/ https://docs.python.org/3 * the poetry documentation * https://pythonpoetry.org https://python-poetry.org the pipenv documentation * https://pipenv.pipa.io/n/latest/ https://pipenv.pipa.io/n/latest the conda documentation * https://docs.conda.io/n/latest/ https://docs.conda.io/n/latest *PyPA, Python Packaging Authority https://www.pipa.io/ https://www.pipa.io. This is the organization that maintains many of the core packaging tools. Online courses and tutorials * look for courses on Python packaging and dependency management on platforms like Udemy, Coursera, and edX. Conclusion. Effective Python package management is a critical skill for any Python developer. By understanding the concepts, using the right tools, and following best practices, you can create more robust, reproducible, and maintainable Python projects. Choose the tool that best fits your project's complexity and requirements. Embrace automation and continuous testing to ensure that your dependencies are secure and up to date. Remember to commit your lock files.